Okay? So if you see the symbol for the first time, you can check what we are using that symbol for in the table, just to aid you. All right? Now, next important tool that we have in science is units. So we have numbers, mathematics, pictures, figures, and then units of things. Simplest thing is we start with measuring length. Length, okay? So we need a unit. And what's the common unit that we use most of the time? Basic length unit? Meter. Okay? What are the common units of time? Second, hour, minute, etc. There are many of them. They are all related to each other. Also true with meter. There's centimeter, kilometer, whatever. One of them we choose as the basic one. The other ones are defined. So the basic unit that we use for time is the second. Okay? The next important kind of quantity in mechanics, beginning science, is mass. How much matter there is. We will learn later on that that just refers to the actual number of pieces of matter, actual number of atoms. That's what mass is, how many atoms. Okay? But in our daily units, we figure out mass in what units? Gram, yes. What else? Kilogram. Ton. Okay, there are many units. And the basic unit that we will use is the kilogram. Short abbreviations are meters, seconds, kilogram. So this system of units is called the MKS, meter, kilogram, second system of units. Or official name is SI, which is short for System International, because some international convention defined these units to be used all over the world, and the convention was for some reason in French. Okay, so that's the SI is the same as MKS. Another system of units that's very often used by scientists is centimeters, grams, seconds. That's called CGS. Okay. But in engineering applications and in many areas of science, MKS is used. So we will use in this course the MKS system of units. Okay? Now, in the MKS system of units, let us think about some of the dimensions, some of the sizes, magnitudes in the universe. Okay. Well, let's say the size of the universe. Okay? We will see how to calculate this number later on, but the size of the universe is usually written like that, 10 to the 26. Now, you have not seen yet, I suppose at least some of you have not seen, what this 10 with the 26 on top means. It means the following. The size of the universe, according to the latest measurements of far galaxies and how the universe is expanding, becoming larger, etc., according to how the universe is expanding, the whole universe, scientists derive this kind of size. Now this symbol, this wiggly symbol here, is red, is of the order of, just very roughly, okay, this number. It is not an exact equality, it's of this order. Now, the important thing is to express this size of the universe, of course, we have to compare it to something, and we write it in our unit, meter. In our human meter unit, this number is very large. The universe is so large in terms of our meters that to write it, I put a 1 and then 26 zeros. It's 10 times, 10 times, 10 times, 10 times, 26 times multiplied together. Okay? You may not remember this number, but the important point here is that it is extremely large. Okay? So, by the way, 10 to the 26 means 1 followed by 26 26 digits, 0 in this case. Okay? Now, I give you an example of the longest distance scale. The whole universe is this big. You may ask, well, okay, this is big, but how do you know it is this big? Maybe it is infinite. Maybe it's even larger than that. This is true. We actually think the universe is infinite. And the number that I wrote is only the part of the universe that, in principle, we can reach by our observations. How does that work? Well, the universe is large. Maybe, very probably, it is infinite. But it started from an origin. There was a Big Bang. Okay, it's now expanding, becoming larger. So in the past it was smaller and smaller. And we can calculate from our observations how long ago was it all on top of, everything on top of each other. Okay, that's called the Big Bang. Now the Big Bang took place roughly 10 billion years ago. And what we can now see are parts of the universe from which signals, light, have come to us. Well, how far can we see? Well, we can see as deep as there was time for light to come to us. Since the universe has been living for 10 to the 10 years, if you multiply 10 to the 10 years with the speed of light, that is the farthest part of the universe from which I can get observations. Clear? So the universe itself may be even larger, but already the part of the universe which since the Big Bang has had time to have its light run at this very fast speed and reach us is already this big. This is the part of the universe that we can in principle see. We haven't yet reached all of it, but we have reached quite close to the edges of this visible part of the universe, observable universe. Okay. Now let us return to our topic, which is just to realize that this is big in our units of meters. Now let me give you an example of something small. What example? Atomic nuclei are the size of an atomic nucleus, atom çekirdeği, is 10 to the minus 14 meters. Again, I am giving you an example of this notation with a little number on top. Let me now write down this small number. Size of the nucleus of an atom is 0.13 zeros and then a 1. Of course, this only means something if I put the unit in meters. Okay. Now let me give you some examples of times that we know. I already mentioned one of them. According to our observation of how far away galaxies are running away from each other, we can deduce how long has this expansion been going on